the Science Guy. Bill Nye, the Science Guy. Bill Nye, the Science Guy.
I'm Bill Nye, the Science Guy, but for today, I'm the Math Guy. So what exactly is a sinusoidal function? Well, sinusoidal functions are everywhere around us. Have you ever wondered what these things have in common?
Yes.
They're all real-life situations that can be modeled using sinusoidal functions.
What's sinusoidal function?
I'm glad you asked. A sinusoidal function is actually a function that repeats itself over and over again in a given time interval. But one very obvious example of a sinusoidal function is actually really fun.
Math and fun? Are you sure?
Well, don't you love the playground?
Well, duh.
Well, you love math too then, because that swing you love so much, that's actually a sinusoidal function.
The motion of the swing can be graphed as a sinusoidal function. Look at it like this. As you move away from the original position, the distance you travel can actually be plotted on a graph.
The rest position of the swing is when it's in the middle. Now that's its starting point.
Oh, I see.
Swing forward, you'll reach your maximum height, which is at...
Oh, I know. 3.5 meters.
That is correct.
And then I fall back to my starting position, which lies on the horizontal line in between my maximum and my minimum point.
And then it reaches the minimum point at negative 2.5.
And then it falls back to the starting position, which marks the end of one cycle. And now you connect it. Wait, it looks like a sinusoidal function.
The fact that this pattern is periodic, a function that repeats in regular intervals or period, and it's smooth as well as repetitive, that's what makes it sinusoidal. Fact! Only cool people like sinusoidal functions.
Wait, what?
Like surfers, because they're so wavy.
Ugh. And now it's transformations with Bill Nye.
So for the a value, if a is greater than 1, it's actually a vertical stretch by a factor of a. If a is greater than 0 but less than 1, it's a vertical compression by a factor of a. And if a is less than 0, then it's actually a reflection in the x-axis. For the value of k, if k is greater than 1, it's actually a horizontal compression by a factor of 1 over k. If k is greater than 0 but less than 1, it's actually a horizontal stretch by a factor of 1 over k. And if k is less than 0, it's a reflection in the y-axis. For the value of d, it's actually a horizontal translation. So if it's a positive value, it translates left, and if it's a negative value, it translates right. For c, it's a vertical translation. So positive number, so plus c means translates up, and negative translates down. Now you know.
Looking at the equation, we see a vertical stretch by a factor of 3, a horizontal compression by a factor of 1 over 120, and a vertical translation up 0.5 units.
Now, how do these things relate?
We could find the amplitude by looking at the vertical distance from the function's axis to the maximum point. We could also find it using the amplitude equation, which is the maximum value minus the minimum value divided by 2. These two methods will both give us the same amplitude of 3. The period is the time it takes for the swing to complete one cycle. This could be calculated mathematically by using 360 degrees divided by the absolute value of k. For our function, our k value is 120, so 360 degrees divided by 120 equals 3. The period of our function is 3. This will also be found by looking at how long it takes for the swing to complete one cycle. To find the equation of axis, you take the maximum value plus the minimum value divided by 2. In our case, the maximum value is 3.5 meters, and the minimum value is negative 2.5 meters. The negative is referring to the direction the swing is traveling. So when you add 3.5 to negative 2.5 divided by 2, you get the equation y equals 0.5.
Why doesn't the graph start at 0?
That's actually because the swing itself is actually 0.5 meters above the ground.
How does the swing work?
A swing actually works by converting potential energy into kinetic energy and then back. And so this means as you swing, you consistently reach the same maximum and minimum height at a given time interval. So that means you could plot that using a sinusoidal function.
Yay!
So why are you the math guy now?
Because math rules.
Thumbs up. Wait, don't move. Oh. No, it's fine. Yeah, no.